I think they're great. Okay, so now, an appliance is not rated in amps, usually. Right? You look on the back, you look on the label, it doesn't say amps, it says watts. Correct? It says watts. So now what do? We have a new term. So far the new terms are voltage and current, or amps. And now we have watts. So watts is the amount of work it's going to do. So in my squirt gun example here, going back to my trusty sidearm, how much work, how much watts can this guy produce when the work is being defined as getting somebody wet? Not much. Yeah, maybe. How much work can this bad boy do? Much more. So that means the watts capable out of this gun is higher than the watts capable, or the work capable out of this gun. Follow me? Okay, is everybody asleep yet? You should be. So now, let's look at our sheet here, number 3, section 3. Who likes pi? I love pi. I love pi. Pi, P, stands for watts. We're going to use some nomenclature from the engineering world. P stands for watts. I stands for current, and E is for volts, or electromotive force. That's why I use E. Now, the engineers back then, they didn't understand that people like pi, right? So, PIE, P equals I times E. Watts is equal to current times volts. We know what volts is, we know what current is, therefore, multiply them together, we get watts. How much work can those two things together do? Right? Pressure on this trigger and how big the pipe is creates work. So pi is equal to current times voltage. Now, the same relationship is we're going to apply. If we have our blender uses 120 volts. We plug into a wall outlet, right? All wall outlets are 120 volts. 120 volts, that's our volts. And it says on the back 600 watts. It takes 600 watts to operate that thing. So it means there's a relationship between the volts, the current, to create watts. It consumes 600 watts, so we need to find the amps. Here's what we do. So if power is equal to current times voltage, that means the ratio of the power divided by the voltage is equal to the current. We can now find the current. So we have 600 watts, that's what it says on the back of the blender, divided by 120 volts equals 5 amps. Now, have I put everybody to sleep yet? Pretty much so. I put this down, hopefully you can see it. Here's why we go through this math. Because I'm having a hot flash, that's why I go through this. We go through the math because these units are rated in watts. Okay? These units are rated in watts or amps, meaning you can get a 1,000 or 2,000 watt generator, but the plug here on the outlet says amps. You have to know the correlation between them to understand what you're purchasing to charge your desired goal item. Either it's a radio, computer, or such. Does that make sense? That's why we're going through the math. It's very important. It's very important. So, let's get busy and have some fun now. Okay? Any questions on the math part? Fully confused and full asleep? Perfect. Perfect. We'll be out of here early then. Okay. So what I have here in front of us is, this is my camper setup. This is what I've got for my camper. And I'm going to talk about the solar panels first. Solar panels have come a long way. Okay, each of these are 15 watt panels. So I put them together, 15, 15, 15 equals 45. 45 watts, combined together in full sunlight with no shade. That's the best they can do. Are they 100% perfect? No. Will I get the full 45 watts out? Maybe-ish, right? I'll get pretty close. I'll get pretty close. But combined together, I can charge up my camper battery, and I can run nearly indefinite if I'm really careful about how I use my camper pump, lights, furnace, right? I've got one big, giant, biggest deep cycle battery that Walmart sells. It's sitting right here in front of you. Isn't that nice? Okay, so when we think of solar panels, we think of watts. There's multiple kinds of solar panels available on the market. I've got the cheap ones. That's why they're so big. Okay, the cheaper they are, the larger they are, because they're only 15 watts. Now, in today's market, you can get a solar panel of this size, combined, the wood combined, which is 45 watts or even bigger. I mean, higher wattage, 60 watts, 90 watts. So that's a newer technology, but their cost is more expensive. The only trade-off is the size and weight, right? So combined together, the days that I bought them, I could probably buy a newer panel about this size now. Does that make sense? Because the technology keeps leapfrogging over time. In today's discussion, we're going to talk about strictly, I have 15 watts of solar panels here available for me to use. Okay? Now, if we look in our handout, and we go to the Solar Electronic Basics, which is the next page over, and since I'm using this as a camper and not as a home, we're going to skip one item in our discussion here, and that is I'm going to go from my solar panel to a charge controller, or this is a good one. This is a house. So let me just talk about how I use my camper, the setup I got right here. There's pictures all throughout this, so you can see how a home installation to run the appliances would work. But right now, just all eyes on deck here. I go from a solar panel directly into a charge controller. This makes sure it doesn't overcharge my battery. Let's say, for example, I have a brand new battery, a battery I just fully charged. It's fully charged. I plugged it in to the wall, and I use my AC charger. It's fully charged. I go camping. I set it up. I put my solar panels out in full sun. I hook it up. If I didn't have this, I could overcharge my battery and kill it. So an overcharged battery or a severely undercharged battery are the two main reasons batteries fail. So the two main reasons batteries fail is because we leave them on the charger for too long, and or we cycle them down below a recovery point. Deep cycle battery, not like a car battery, but a deep cycle battery is designed to go from the extremes. Fully charged, nearly fully discharged, and back again. That's the deep cycle, a big full range of current usage or voltage. The voltage, the amp hours are full, it's reduced down to almost nothing. A car battery, a normal car battery, is not designed for that. A normal car battery is designed for quick turns. How many times can you turn your car over on a cold morning before the battery's dead? Not many, right? It goes da-da-da-da-da-da-da-da, finally dies. So there's a difference between a regular car battery and a deep cycle battery. Always choose deep cycle batteries whenever we work with alternative power. Okay? Always use deep cycle batteries. Now, charge controller, make sure it will shut off the power to the battery if the battery says it's full. That's what a charge controller does. Now, I have lots of equipment that will run off of 12 volts directly. So I spliced into my line they're called Anderson connectors.